Welcome again. This is our first virtual GA4GH plenary, and it is our most diverse plenary. The participants who have registered from all of these countries all around the world. We haven't made it to Antarctica yet, but that will be for the next virtual plenary. And as I mentioned, there's both English closed captioning that you can get, I think, on the Zoom system, and also simultaneous translation to Japanese, Spanish, German, and French. So do type in this URL, bit.ly/GA4GH-translation, or get your mobile phone app out and look at that. Great. So we'd also like you to give your feedback, in particularly because this is such a global audience. We want to understand your views about equity, diversity, and inclusion across the world and across different aspects of society to GA4GH. So please go to this slide and this URL and this slide deck. Thank you very much as well for attending. We know that this is a strange time. It's many of you have been working hard on COVID, or work hard on COVID every day, or do research around that. And we've taken the opportunity of making this virtual. That's why we can talk to many more of you here. But there's lots of things to adjust for, and we really, really appreciate your time. The GA4GH community has responded to COVID, and you can understand more by going to this URL, ga4gh.org/COVID-19. Great. Just a reminder, if you're not used to Zoom, it's sometimes more pleasant to use external headphones. Do make sure that you have a good local internet connection, that you're close to your Wi-Fi hub at home or wherever, or your on-wired connection, and mute yourself when you're not speaking. We're here to help. So you can type into the chat box and we can see it on the plenary website or on here on the Zoom. You can ask questions on the Questions for the Secretariat Slack channel. So download Slack and join the GA4GH Slack. Or if you're a bit more old-fashioned, you can simply send good 1990s email at operations@ga4gh.org. So this is the URL to go to for the next 2 days, today and tomorrow. So again, bit.ly/GA4GH-2020. This is a place where you can see where to go, where to visit, how to get to the poster sessions, which is great fun, by the way, and how to participate in this virtual conference. Use Slack as a way of communicating during the conference. You can tweet. I tweet a fair bit. You can book some meetings if you want to. And there's this wonderful virtual lounge called spatial.chat. Now, that's 2 a.m. in the morning for me. And so sadly, I will not be making it to the spatial lounge tonight. But I hope some of my North American colleagues will be there with a glass of beer or a glass of beer or a glass of wine beside them. It really works. It's a great way to meet people. I recommend the slightly cheesy 1970s bar layout. Now we'd like to test whether you can ask questions here to the panelists, which will happen in the future. And rather dangerously, Angela and the team have decided that this test question should be to ask me almost anything. So please ask away, ask anything you like about myself. And I think Justina will probably flip, won't you, Justina, to the Slido screen. Here we go. Good question. Let's see the rest of you do the questions here. Rate them up. Let's get some more questions in here. I'll ask you the first one from Heidi Rehm, highly rated. The glass of Riesling was very nice, actually. I like a dry white Riesling German style. So thank you, it was lovely. What time is it where I am? It is 11 p.m. in lovely London. The cats are active in the house at the moment, so they're just going in and out of the cat flap. What was my first car? Well, my first car was a Volkswagen Golf, but my first car was a convertible Z3 BMW bought with the receipt of a .com boom that I got a small windfall from. So that was my first serious car. Who is my favorite scientist? This is really, really tough. It is really tough. I mean, I have to admit, I increasingly think it's Alan Turing who brings together computers and biology, and obviously dealt with a just ridiculously stupid prejudice and very sadly killed himself. So favorite is not quite the right word, but if there's one scientist who I wish that I could meet, it would be Alan Turing. So I think this is going to be the last question, which is, going to the top, R or Python for bioinformatics. I have to admit, I'm an R and Perl person. I know I should be with the cool kids and do Python, and all my students do Python, but somehow I just can't do the tab thing. So it's R and Perl for me. Just shows my age. Okay, we should switch back. Wonderful. Stop quizzing me. So you clearly know how to use Slido, and that is great. So I believe I can actually, yes. At 1 a.m., do come to 1 a.m. UTC. On that plenary page, you'll find it in other time zones. Come to this spatial app website. It really works. You can go to posters and you can also go to the bar. And this, I believe, is a video of that working. Is that right, Justina? Do I play it? Here we go. Wow. Here we have this app in action. You're a little bubble, and the bubbles, when the bubbles are close, you talk to each other. It really works. It's slightly bizarre, but it's quite natural. So please try it out. It's the best discovery I've made for virtual networking. We'd also like to hear your story. So please go to the video booth and record yourself, your thoughts about GA4GH, which we'll probably convert into a cheesy video at the end and use in shameless marketing of GA4GH. So be nice. These presentations will be up. So if you've woken up and you really wanted to see track 1A, the importance of diversity in genomic datasets, you can get it from the website shortly. But we are in track 2, track 2A and track 2B. So we had genomic diversity, importance of diversity in genomic datasets, and then bringing together the ethical and technical solutions to harness the power of data. Sorry, that's now is this track 1B, bringing together ethical and technical solutions. Tomorrow is about real world implementations, and 2A is the CanDig and implementations from CanDig, BitMed and Genomics England. and 2B is your time zone, Australia, Japan, and China, so Australian genomics and Japan. This should be obvious, but we have to, well, it's very wise to be very explicit about these things. So we expect good conduct online as well as in person. So be respectful, be transparent about potential conflicts of interest, and we will not tolerate discrimination, harassment, sexual harassment, disrespectful behaviors, or violence. So many thanks to the program committee members, some of whom are panelists here and some of whom are, I think, in the audience. So thank you so much for this really diverse set of program committee members here. And then we have, coming up soon, you'll see an extensive piece of analysis by Heidi and Andrew on gap analysis. I'd like to give a big shout out to the Melbourne crew, in particular, Oliver and others, for giving up their wonderful physical slot. We will visit Melbourne in the future. And also thank you to the GA4GH Secretariat that made all of this possible. So with that introduction and housekeeping, I will now switch to talking about the Global Alliance for Genomics and Health, GA4GH. So what are we? GA4GH is a policy framing and technical standard setting organization seeking to enable responsible genomic data sharing within a human rights framework. Every country that has signed up to the UN Declaration of Human Rights has some human rights about science, the right to participate in science and the right to access science. And we are activating those human rights. But we are doing that in a responsible way through our policy sharing. And most importantly, we're enabling that responsible federation of data via our quite comprehensive technical standards. So what is GA4GH? Well, we're really a community. We have over 600 organizations have signed up. They span 90 different countries. We have 3,000 personal subscribers and many more who use our standards. We have 24 concrete driver projects. Now, you do not have to be a member of one of these driver projects to participate or indeed lead in GA4GH. We're a completely open organization. But we want to be grounded in the standards that we develop. And so we have deliberately interacted with these 24 projects to make sure our standards are grounded in the real world. We are organized into 8 different work streams. That's how we organize. There's an awful lot of Zoom and Google Docs to achieve that. We have already developed 20 technical standards, some of which you will hear about. We've developed 7 regulatory and ethics policies and frameworks. These are documents that help frame regulatory and policy issues. And although we, GA4GH, don't implement things, we're not a coding shop, we're not a place that holds data. Of course, our driver projects and on our community have many, many implementations of these standards. These standards are not abstract things, they are things that really work. And all of this enables the global health learning system. So this is a slide that illustrates that journey of how data comes from individuals and helps improve research and health. So patients or citizens agree to donate their data, and they do that in a way which is managed and informed by research and ethics committees. That data will be looked after, stewardship by a data access committee as it's placed into a database and used. But the whole reason to do this is to allow researchers and clinicians to access the data and make discoveries. Now, GA4GH standards are throughout this journey. So this is a busy slide, and the slide, but it shows how GA4GH is at all these different places. So at the start, a lot of the policy is framed by the regulatory and ethics about the different aspects of the way consent and ethics should be localized and written consistent with national laws, but enabling responsible international data sharing. As it goes to the Data Research Ethics Committee and the Data Access Committee, we have ways of making the statements electronic wherever possible. And that will allow for faster matching between requests to access data and consents that people have signed to use data. And then you can see that as the data moves to the researcher or clinician, there is a huge suite of things that she can use to access that data, about finding the data, about the formats in which the data is in, about a cloud framework to use the data, all enabled by a comprehensive security framework, which she participates in, authenticates with, and authorizes her work with. And eventually, she hopefully creates wonderful new results and publishes, but also provides feedback through the appropriate way to patient groups. And with that overview, I'd now like to hand over to the Vice Chair, Heidi Rehm, who along with Andrew Morris undertook a key gap analysis for our strategic roadmap. So every 2 years, we aim to update our roadmap, which tells us where we're going and lets you, the community, understand the direction of travel of GA4GH. So take it away, Heidi.
Thanks. Thanks, Ewan. It's a delight to talk about our 2-year roadmap. Justina, do I have control yet? There we go. Okay. So there's actually 2 components to our roadmap. One is a strategic roadmap informed by our gap analysis, which I'll talk about in a second. And the second part is our product roadmap, really informed by our work streams. Both are publicly available, and so you have access to the slides. You can go online and read the full detailed versions. So the strategic roadmap, as I mentioned, was informed by this gap analysis that Andrew Morris and myself led. And the goal was really to take a top-down approach and identify gaps that may not arise during the work stream roadmap process, where each of our teams are really in the weeds, thinking about solutions in their area, but we wanted to make sure that we took a high-level look and made sure we didn't have any major gaps. So to do that, we conducted a survey. We held a lot of conference calls with all of our work streams and driver projects to gather feedback and input, both verbally and written. And then that feedback was collected, it was consolidated into specific concepts. And then those concepts were actually ranked in importance for Global Alliance by our steering committee. That led to the selection of the top 6 or so that were coalesced into 3 major areas of focus. So I'm just going to briefly go over those 3 areas in terms of the strategic roadmap focus. One is in interoperability and alignment. And here it's really about ensuring that the standards that we develop are each interoperable with each other and are aligned so that they can be put together as a suite of standards and really support real live use cases that we need to support. And success is really, ensuring those are interoperable, that enable actual solutions, bringing multiple components of a pipeline and multiple platforms together. How we're approaching this is through our technical alignment subcommittee that spans across our work stream. So we ensure alignment and communication and shared activities through schema blocks that are shared semantics and objects and other things to ensure the core building blocks of our standards are in fact the same. And then through actual connection demonstrations of the use of the standards. And we'll actually see some of those in a few slides. The second area was really in implementation support. So we've focused a lot over the last couple of years in building the standards and getting them approved for use, but we had feedback that more support in actually implementing those standards, hardening them, ensuring they're actually working okay is critical to enable quick adoption by the community and implementation and broad uptake. The tactics we're taking to support that are supporting more reference implementations, documentation tooling. We have the Global Alliance Planet API. It's a registry of our standards. And then also through the connection demonstrations that we'll show you shortly. And then also online resources and in-person training seminars, live and recorded webinars, a lot of educational forums for understanding and supporting the implementations. And then the third area was really increase engagement with healthcare and clinical standards. And here we really want to efficiently and effectively respond to the needs of clinical stakeholders, which are varied. We have EHRs, providers, insurance payers, clinical laboratories, all of those different stakeholders in the clinical area, and ensuring that standards that both we develop and other standards bodies in the clinical space are coordinated and supporting this industry. How are we doing that? One is through our Genomics and Health Implementation Forum that Catherine North and Andrew or Mark Caulfield have been running. That evolved out of a national initiatives activity, meetings that were ongoing to help with practical implementation in genomic initiatives, but it's now really become our formal implementation forum, particularly engaging with the healthcare side of things. Also, our cross-standard development organizations consortium, really working with HL7, CDISC, ISO, the other standards bodies that work in this space. And then last, and this is on the to-do list, is to develop a clinical advisory group that spans the different stakeholders to ensure that we're hearing feedback and input and being responsive to the community needs. So in terms of the actual product roadmap, we have a series of new deliverables for this 2-year period. You can see each of the work streams listed there with a number of standards and policies that they are working on. I won't go through them all, but they are outlined in the product roadmap. And this will then join a growing list of already approved deliverables from these work groups. They've been very busy. We're delighted with the progress that's being made across the Global Alliance work streams. With that, as I mentioned, we wanted more focus on actual implementations, and these connection demos are really a real live example of that. So first, we're going to show you an actual animated video that's really cool to give you a sense of where we are headed, and then I'll dive into a few details.
University Hospital is a global leader in infectious disease research. Anna is a member of the UH faculty, where she leads a team in studying a deadly pathogenic disease. Like many of her colleagues, Anna would like to work with more datasets around the world in order to analyze the genomic and health-related data of as many patients as she can, in order to identify genetic variants associated with better outcomes and guide better clinical treatments. Similarly, UH and institutions like it want to make their troves of data available to researchers like Anna. But without interoperable methods for researchers to efficiently identify, access, and analyze data of interest to them, none of this is possible. Right now, Anna's team can easily interrogate local UH data, but working with datasets around the world is challenging. Without large interoperable cohorts, the statistical significance of their results remains low, limiting their ability to advance the field. But it doesn't have to be this way. A suite of software tools powered by GA4GH standards can connect researchers like Anna to a global network of data in a secure and responsible way, unlocking its potential to benefit human health. First, the GA4GH Discovery APIs allow data stewards to make their datasets findable. Anna can query this large network to identify datasets that are relevant to her study. For each dataset she wants to analyze, Anna works with the corresponding data access committee to acquire permission. GA4GH standards help these groups to reliably determine whether Anna's proposal is within the scope originally agreed to by the data donors. Her approved requests are added to her virtual identity. And now she can begin working with the data. With the GA4GH Cloud APIs, Anna's lab is transformed into a virtual hub, connecting her to all the data she needs to do her job well, although she will instruct software machines to carry out much of that work on her behalf. Anna tells each machine where to go, what data to analyze, and which analysis tool to use. Equipped with these instructions, the software machines head out to analyze a portion of the data right where it sits. Only machines with authorized access to this data are allowed to enter. The machines carry out Anna's instructions, which is made possible because the institution has packaged its data in a universal way, also according to GA4GH cloud standards. Each machine brings back its analysis result to feed into Anna's study. As a security measure, the data steward may remove access from Anna's software machines once the analysis is complete. Anna's team fits the pieces together to reveal a genetic variant associated with better outcomes, a new insight they could never have seen if the datasets were not interoperable. Anna is just one researcher, but her story isn't unique. Someday, we hope that every researcher in the world can access a global network of data from the comfort of their lab, revealing otherwise hidden knowledge of human health and disease.
Great. So that is where we are headed, the full Monty. And now I'm going to share with you a little bit about exactly where we are today. So we have a few sort of connection demos that are examples of what's been achieved. So in this case, we're thinking about this from a horizontal connections. And here we're talking about one task that can be performed in a reliable and reproducible way across multiple different sites and platforms. So this is an implementation by DNA Stack, Terra at the Broad, Elixir, and 7 Bridges that have all implemented consistent single task standards that are portable. And the example is a GWAS analysis of 1,000 genomes data performed in multiple systems. So this is a real live demonstration of the use of our standards, but more in a horizontal way with just a single task. The next example is we think about is vertical connection. So this is really end-to-end use of standards within a single system. So here you can see within DNA Stack, they have implemented multiple standards to allow an end-to-end controlled access use case, also involving multiple cloud environments, both Google Cloud and Amazon Web Services. And you can see it's involving different standards, the blue blocks here, like WES and DERS and passports and search APIs, all enabling this end-to-end use case. So that's sort of the vertical connection demonstration. Next, we have really thinking about cross-platform connections. So that this is being able to do science across these systems with multiple vendors that are production ready, interoperable standards. And this is where we are right now, really working together in the framework to offer a path to enable access to multiple data sets from multiple platforms. Now you can see there are still some pieces in here that are not based on interoperable standards, that rely still on some pieces of the puzzle that are specific to each system, but it's still getting closer to complete interoperability across these systems. So where we are today is really this vision. And these are examples of cross-platform connections that have been made in this kind of environment. On the top are the actual groups that have made these connections. Below the line there are sources of data and places that the data is being stored and accessed to support these actual connection demonstrations. The next step, which we plan to achieve in 2021, is where there's full interoperability, so that a single execution can cross platforms in real time, pulling data from different places and using different components across the platforms. And that's really where we're headed. And that is what will also enable Anna to achieve exactly what that animated video with the really cool robots shows. So it's really exciting that we've come a long way, I have to say, and are really getting to the point of interoperability. So if you're interested in getting involved, either learning more about these demonstration projects in more detail than I shared today, there are links to the demos, breakout sessions tomorrow that you can join for a deeper dive. If you're actually, interested in being part of the development of these demonstration projects and implementing the standards, there's a link to Fast Minutes, and you can get more involved in a more detailed way. If you're interested in implementing standards and want to just learn more about what those standards are and whether they're useful for your environment, you can go to the sort of deploy here. And Rishi is an excellent contact to help you navigate this space. So I also wanted just to acknowledge that none of this work would be possible without incredible support from the funders we've had to date and the funding that will come in the future. And so the team has put together a little montage of words from our funders, who we're delighted are as committed to this effort as we are as well. So we're going to play a little clip from our funders.
With massive advances in the field of genomics and substantial reductions in the cost
and you
of
might have to
genomic
turn up your volume at your
we're
end.
accumulating untold stores of genomic data.
Sharing data and empowering a worldwide research community to use these data to answer important questions in human health plays a hugely important role in open research and the use and reuse of data and its reproducibility.
But at the moment that is compromised by the use of different terminologies and different data models and so on.
It's only through standards that we can actually have this kind of vision for interoperability and federation.
But it doesn't happen by magic. And it definitely doesn't happen if everybody's working independently and doing different things.
And we've come to realize that there's no one-size-fits-all solution.
The Global Alliance for Genomics and Health is key to advancing the effort around standards due to the engagement, depth, and breadth of its community.
GA4GH is, in my view, one of the best examples of an organisation really leading the way in how to do this well.
In fact, we cite the Global Alliance as an exemplar of how we can work internationally on such standards.
It's what Global Alliance does to build a global community, and never has this been more important than now during the COVID-19 pandemic, where we need to bring scientists, clinicians, people from all regions together to solve a global problem.
Because no one group has a monopoly on good ideas. And it's only through collaboration that we can exchange ideas, share knowledge, and come together to make fundamental advances for science and medicine.
Further, if we want to be making advances that benefit human health, we need to be considering human health for all people, not just a portion of the people.
To bring ethics and human rights perspectives to technical solutions. Such perspectives help to minimize legacy or societal inequalities.
That is why an organization like the Global Alliance for Genomics and Health is so essential, championing the human rights of privacy, non-discrimination, and fairness, and to ensure that all citizens benefit from scientific advances.
So I'm very excited about the work of the GA4GH and what it means to the future of science and medicine.